what it really requires is you to think about it and see why we defined it that way, or at the very least understand what we defined it as, and then you move forward. And you know, she can't, until she understands those basics, she's not going to understand the next step, right? So, you know, you're going to be, by the third hour, you're going to be confused. Guess what? That's why I gave you these notes. I'm telling you, like I've been there as a person who knows how to study for exams and also skip a lot of classes. The easiest way is just before you come in here, reread the notes from the day before, refreshes your mind, you'll realize what I was talking about, bang, away we go, okay? That's the best way. Stay on top of it. Because the one good thing that will kill you here is if you fall behind. You will be there. Right? That's always good. That's why I try to keep these exams on. Okay, any burning questions? For those of you who were not here last day, first thing to know, I don't care. But on the other hand, it's for you to catch up. You miss a class, you come late, I'm not really interested in telling you what I already talked about. It's for you to keep up. We're in this, we're marching, there's things to learn. You hook up and join the crew, right? We're not going at your pace, number one. But we have these packages, you'll need them. Get them, they're $10, next week they're $15. And next week they're yeah, so that's good. So that's all we need, and now we progress. So we're talking about production possibility curves. Basically, I hope you did some of the problem sets. I'm not going to realize we're just starting, it's hard to get in gear. But today, in this first hour, we're going to get to more on opportunity cost, and we're going to get to a core idea, and then I'll really stress that. Then we're going to hopefully finish this stuff now, and then we're going to go to demand and supply. We're going to define demand, and we're going to do this, right? So, by the end of the day, we should have defined demand, broadly defined the supply, and broadly understand how they might shift. And therefore, you can then do the problem set tomorrow or on Tuesday. Okay, everybody? Never be afraid to ask questions. Sometimes people say, speak too quickly. Well, if that's the case, stop me. Say, are you talking too quickly? Okay, so just remember now, capital stock, investment, depreciation, net investment, labor, entrepreneurship, we don't really care about it. It's, you know, it's an interesting philosophical discussion, but we're not interested in first years. Okay, and also, now I want you, because people you know will use terms like investment and profit and wages, and people always talk about economics. Connect. Listen to the conversation. Read things in the paper. Pay attention. See if you can think about it, right? You'll find that it will start making sense to you. Talk to people. Debate with people, right? That's the way you help sharpen your own thinking. And by all means, talk to each other. Okay, so then we did a production possibility curve. Remembering that it was maximum output possibilities. I gave you this example. We looked at that. This gives you the various, the lineups, the various opportunity costs. Now what I'm going to do in this exam, by the way, is this. I'm not going to give you this in this order. I'm going to give you this in some abstract order or something. And the first step, like for example, I might have Ontario at 3.3, BC at 1.5, etc. Right? So your first step is to organize it in a table. Then your second step will be the graphics. Okay? I'm hoping that you won't bomb out in the initial organization, because sometimes that happens. Okay, this is an example of something I was drawing yesterday. I'll just, in that class, it's more useful for me to draw up here, but I'll draw here because when I type, you might not be able to understand what I'm saying. This is the production possibility curve. See the red dots? Of that example that I gave you last day. Don't worry about this, I'll move it out of the way. Ignore this, I'll move it out of the way. There's that. Okay, now, if it was only, as I said to you last day, each, remember, there's a difference between resource cost and opportunity cost. The resource cost was that every one of those regions had 1 million hours of labor, 1 million units of capital, 1 million hectares of land. So there was only, and they only could produce one or other. So we started with 23 wheat and Navapos, then we shifted Ontario, then we shifted New Brunswick. So let me move this out of here. We wouldn't really have anything in between here in general, right? So we would have got these points, strictly speaking. But when I ask you to draw this, I want you to draw a curve, right? So you would draw in here. This is strictly a straight line between these 2 points. In this case, it's strictly a straight line between these because they have the same opportunity cost per unit. This one is a straight line like that. Then this one is a straight line within those points, and then here. Now overall, you see this curve is essentially concave. But there are points where between, for example, Ontario and Quebec, it's not concave, it's linear. Why is it linear between Ontario and Quebec? Remember? Yes. Yeah, go ahead.
Yeah, same opportunity.
Because they have the same opportunity cost. Now, they literally have the same opportunity cost per unit. 3 apples cost 3 wheat. You could have 3 apples cost 3 wheat, 4 apples cost 3 wheat. So they have the same opportunity cost, but one you gain 4 and the other one you gain 3. So it's the opportunity cost per unit, which is the most important. On a diagram, that's the slope. The slope is the change. I used the little d there to use change, delta. It's not being infinitesimal, it's just the only thing I can use to draw that up in that particular program. So the slope is the rise over the run, the change in y for the change in x, right? And so initially, the rise over the run is 5 apples are gained at the loss of one wheat. So the opportunity cost per wheat or per apple is 1/5. The slope is 1/5. Now, for those of you who are completely comfortable with slopes and everything, fine, don't worry. But for those of you who aren't, I'm trying to make sure you understand what I'm talking about. Because this stuff is actually easy, but you do forget. Like, I was really good at math as a kid, like really good. I didn't even know how I did stuff. I didn't know how to do it. But then I didn't do math for a couple of years, and I was just amazed. Like, what is this stuff? You know? I don't know what. I kind of lost it. I couldn't, once I could just see it. Now I couldn't even think, what is a slope? You know, so if you're rusty, it can be a bit of a challenge initially, a bit of a fright. But it's not. Just learn it like any other language. Okay, now then, we recall. Last day we said this is, for the most part, this is concave. And when I give you questions, I'll just get rid of this stuff here for a moment. When I ask you to do something, I'm going to set it up so that all I'm interested in is basically when you draw it, I'm interested in this point here, in this case. That's that intercept term there. And this point here, what did I do there? I lost something. Interesting. I think I'll stick it over here somewhere. This point here, like this, okay, so there's that axis. So this thing is here. And then your question is this. It'll either be linear, and how will you recognize if it's linear? If it's a straight line. How will you recognize that the production possibility curve, if I give you some information, is a straight line? How will you recognize it? It'll have the same opportunity cost every time. That's all you're looking for. So in this exam, I'm going to give you a linear or something else, right? I'll give you linear, same opportunity cost. If opportunity cost is what? In this case, what is happening to opportunity cost? Is it the same? No, what is it? It's what?
Increasing.
It's increasing, yes, it's increasing. Now the way that I set it up for you guys, in the kind of examples that I gave there, examples I gave in all the other previous exams, it's increasing. But I'll probably scramble it this time. So you realize you're going to put it to be increasing and then you plot it, right? Everybody? Just think about it. You're going to see that this is shockingly common. It took 2,500 years, 2,300 years, say, to discover something that in a sense everybody realizes. Opportunity to maximize production, you minimize opportunity costs, right? I'll give you a better example later. So that's how you do it. Now, the question is, why is the slope shaped like it's concave? Because we're maximizing production, therefore we're minimizing opportunity costs. There, the slope is flat as there. The opportunity cost is the absolute value of the slope. The slope all the way along here is negative. But as an absolute value, this is the smallest absolute value. This is the highest absolute value. And also, if I said to you, what is the cost of a peach? Would you tell me minus $1? No. Cost implies minus. You give up $1. So opportunity cost is a positive number. So therefore, when we look at it, it's what we call the absolute value, the positive value, the magnitude of the number. So the slope, actually the slope up there is 1/5, minus 1/5, right? Because y falls when x goes up, it's minus 1/5. But the opportunity cost is 1/5. Everybody? Okay? Now this is very basic stuff, but you must understand, if you understand the basic stuff, you'll be away to the races. Okay, good. Now then, everybody, a question I would oftentimes ask in the exam, could be a multiple choice. I want to know if this is a production possibility curve, and the reason why it is or is not. Can that be a production possibility curve? Huh?
Doesn't maximize output.
You're saying what?
It doesn't maximize output.
She's absolutely correct. Number one, it doesn't maximize output. That's why it isn't a production possibility curve, as a definitional matter. How do you know it doesn't maximize output? That's the next question. How do you know it doesn't guess?
Well, if you just imagine, like switching each point around, rotating it like this.
Yeah.
Does that make sense?
Yeah.
It's not very
No, you got it. If you imagine there's something that's wrong here, that it can't be right. What is it? What's happening here? Yeah.
The opportunity cost is decreasing.
Yeah, the opportunity cost is decreasing. You're backwards, right? You didn't arrange this properly. Because what happened is, instead of taking the one with the least opportunity cost, you took the one with the most opportunity cost. Hey, this is a long weekend. Surely people are going to have some serious fun, right? Now it turns out you have to meet me, say, this weekend for 1 hour. When are you going to meet me? Friday night when you're partying hard, Saturday night when you're partying hard, Sunday night when you might be with your family, you're going to meet me? When are you going to meet me? You're going to minimize your opportunity cost. You're going to say, I'm going to meet the guy when I'm totally and utterly bored. You know, Sunday morning, 10 o'clock. Okay, I'll meet you for 1 hour. That's my lowest hour. I'll give it to you. You're not going to give me the best hour, are you? You're always minimizing opportunity cost. Every single minute of your day. Right? So we're going to see that later. So this is a very simple idea. Minimize opportunity cost to maximize your output. Okay, now, and of course, opportunity cost, remember, it's different from resource cost. It's the cost of the best foregone option. So it's always in terms of the other option. All right, now, so we got that. Now, by the way, if, as I said, we did this last day. Let me get this out of here. If we were at, let us say, this point here, can we do that? Can we do that? No, why not? We don't have the resources, either the land, the labor, or the capital, or what else might be the problem? We don't have the technology, right? If we had the technology, we could probably produce more. Now, by the way, now notice, now we're going to link in our concept. If we want to produce more in a society, we either to increase technology, which we're not going to necessarily discuss here, or we have to increase resources. We have to have more immigration, or what? We need more land, or what? We need more what? Capital. And, you know, weirdly, economists, I think it's kind of weird, they only concentrate on capital. They don't think of the importance, you know, to a country of immigration. As far as they're concerned, it's just people. And if they talk about full employment, everybody's fully employed. Well, if you have more capital and everybody's fully employed, who's going to run the new machines? But oftentimes they don't talk about that. I think of Canada and what Canada's done in the last 50 years. Obviously, a lot of the increase in output in Canada is technological, more machines and more capital, everybody. But a lot of it is immigration. But even more than that, more immigration is probably more than this. But a lot of it is this. Where do we get a huge increase in our laboring population in the last 50 years. Besides immigration, where do you think our workers came from? Women. How about today, almost 70% of all women, like over the ages of 16 and to 90, who are capable of being in the workforce, 70% of such women, almost 70% are in the working force. There's more women now in the working force than there is men. Men are literally turning into being drones. And this is important for the guys in the room. News, the party is over. 10,000 years, it's over. It's been over for 50 years. You guys have to snap to it, or you're going to be, your butts will be kicked and you'll be sweeping floors in the future. That's it. What percentage of women were in the workforce in 1950? You know? 20, yes, 20%. So we've got a 50% increase, right? More like half of women are now in the workforce that weren't in the workforce before, which is astounding. So those kind of things, many economists completely ignore them, right? But in fact, when we look at the rules, that's why Canada can produce more and more and more and more. Okay. We need more capital. How do we get more capital? Just buy the law. How would we get more capital? Yes. Investment. Very good. Right. Just investment, people? She's on top of it. It's investment. But is it just investment? I'm not being critical. Yeah. Net investment. Net investment. We have to add more machines, say, than break down. Right? Now that's why, for example, do you realize in this city, again, I'm that clown who's the mayor of the city, part of the problem in this city that we don't have subways is, as we'll talk later in the course, we had a subway built on the Shepherd Line. That was like $1 billion white elephant boondoggle. Nobody's using it. It doesn't cover its own costs as a product. It's just a white elephant. It's in the wrong place, right? But basically, this city, if you think about it, except for that Shepherd Line, most of the subways in this city were built in the 1950s and the 1960s. There's a little bit like an extension from Yorkdale to Finch, built in the 1970s, and like an extension, a couple of stations east and west. The 1950s and 1960s, right? So if we want the city to be bigger and better, we have to have more investment. We need more subways, we need more something. I used to love subways until Bob Ford got subways. Now I'm not sure I want to mention subways. But no matter. That kind of thing. So investment is really important for allowing us to produce more. If we want to produce more, we need investment. Net investment. Okay? Good. So these are basic ideas that are shown by this diagram, but they also allow us, when we deal with this diagram, we're clarifying these ideas, hopefully. All right, let's jump back. So that takes us essentially this whole business here, which of course, now this just shows you figuring out specifically how to arrange the maximum output possibilities, the opportunity cost per option, and the opportunity cost per unit of apples. Remember, opportunity cost moves in two directions. So, like this, where am I here? Where's my diagram? Oh, yeah. In this case, opportunity cost is increasing in this direction, but also you could go back in this direction and opportunity cost is increasing. Okay? So, just a couple of things. Notice here I talk about opportunity cost. The cost in terms of the best foregone option, distinction from resource cost. Define it as the positive value, the absolute value. I'm missing something there. Yeah, this is just, typically the opportunity cost per unit, that's the opportunity cost per option. The opportunity cost per unit is this, right? So you want to remember this. Opportunity cost is the change in something relative to the change in something else, all right? Okay, good. And I'm not going to go through this too much more because you have problem sets, and the best way to do it is to work through the problem set for these basic ideas. And I showed you that drawing that we did that last day. We talked a little bit about it. The slope is negative. We know why, because if you're on the production possibility curve, you're fully employed. To produce more of one thing, you want to take resources out of the other, and therefore resources opportunity, the other thing falls. So when you're fully employed, now this is an important idea. When you're fully employed, if you're working 8 hours a day, you know, building a deck, and you want to paint, then to paint, you must spend less time on the deck. It's that simple. That's all there is to it, right? But here's a question for you. You can work 8 hours a day. It turns out you're working 4 hours a day on the deck. But now I say, hey, can you paint 4 hours a day? What is the opportunity cost of painting 4 hours a day? Zero, because you're not giving up anything. You're not giving up anything, right? Because it's only when you're giving up something that there's an opportunity cost. That's very important. So we assume that you're fully employed. Remember that, because the economy is not always fully employed. So for example, I'll go here. Here we have us inside here somewhere. Okay, now here I am. If I move from okay, there. Here I am. This is us. And now I'm going to move to here. Are you ready? There's an opportunity cost. You can see what it is. What is it, by the way? It is this. Notice it's the rise over the run. I lose this amount of y to gain this amount of x, right? It's this divided by this per unit, the slope. Okay, now, what if, on the other hand, I'm here. I'll put myself right here, right here. What is the opportunity cost of going from here to here? What is the opportunity cost of that? Huh? Is it exactly zero? Let's look at it. It's not like I'm going from here to here. Am I giving up anything? I'm gaining this, but I'm also gaining the other, right? I'm doing essentially this. I'm gaining this, right? I gain that. But then I also gain this. So there's no opportunity cost at all here, is there? Everybody? And if I went from here to here, there is no opportunity cost. But if I went from here to here, what is the opportunity cost? Can you see it? From here to here, no opportunity cost. From here to here, the opportunity cost would be I lose this. Everybody? Right? So it's now when you do this stuff, it's oftentimes you're so overtrained in a way, and I want to make sure you see it rather than just try to be formulaic about it. Because sometimes I'll just be completely baffled, I can't figure it out. And it's, don't worry about it. When it comes down to it, the opportunity cost is what you give up. Look at it. If there's nothing given up, it's not an opportunity cost. And all you're interested in is what you gave up, right? Okay, now, I'm going to emphasize that in other ways later. So that's important to recognize that. So sometimes, for example, I'll show you jumping back here. I'll go, like here's our line, no, wait a minute. I'll go do something like this. So I'll say, what is the opportunity cost? Let's look at it. An exam. What is the opportunity cost? Now remember, you can go in both directions. So, what is the opportunity cost, as we saw last day, of going from 60 libraries to 70 libraries? And the opportunity cost is 6 Ferris wheels. The opportunity cost per unit is 6 Ferris wheels for 10 libraries, which is 0.6. On the other hand, I can do the same thing. What is the opportunity cost of getting going from 12 to 18 Ferris wheels. We gain 6 Ferris wheels, but we lose 15 live rails. So the opportunity cost per unit is 15 over 6. Everybody, so far so good. Let's switch back. Now I want to know, what is the opportunity cost of going from 45 and 12? Supposing we're at 45 and 12 right now. Okay, I'm telling you, we're presently producing 45 units and 12 units. What is the opportunity cost of increasing output to 60? What is it? 0. Why? Because we had some unemployed resources at 12. For some reason, we had unemployed resources. They can produce more, we don't have to give up anything, right? Now, if I said to you, what if we go from 45 and 14 to 60? What's the opportunity cost? Well, it's 2, because we lose 2. Everybody? So it's really quite straightforward, as it turns out. So just think about it, and it'll be fairly straightforward, I hope. Where are we? So we did all that stuff. We're doing all that, marching along. Read this and reinforce. We're going to get to linear stuff in a minute, which, by the way, is very simple. But almost immediately people go, oh, I can't do that. But yes, you can. Now, I'll see if I can find it. I'll show you something. If I can't, I'll just explain it to you. This one will do. Okay, first of all, before I get to this, I'm going to ask you a very simple question. Very simple question. I'm thinking of building a railway from Churchill, Manitoba to Tuktoyaktuk. That must be like 1,500 kilometers, maybe even 2,000. I think it's about 1,500. Okay, do you know where that is? It's in the Northwest Territories, Nunavut, right, the whole bit. You know what that place looks like up there? I'm going to build a railway. Okay, I think I'd like you guys to put up some money. I'd like you to give me some money for my railway, right? Lend me some money. Why don't you invest in, buy shares in my railway? You want to say invest, right? Buy shares in my railway. And I promise you a 1% return for every $100 you give.